Hi, everyone. Can you hear me? Yeah. We're ready to start. Find a seat. Okay, welcome to my second session today about unit testing patterns for concurrent code. Who was in my first session? Okay, so I guess you already know about this. So briefly, I'm a consultant, software architect, help the development teams and developers write better code. Essentially, very passionate about unit testing, test-driven development, clean code. I think everybody should do it. 3 courses on Pluralsight, 2 on unit testing in C++, and 1 on AWS Lambda. I have a blog, helpercode.com, and Twitter handle, which some of you already found. And let's start. Let's talk about the amazing world we live in right now. We are, well, used to say in the middle, but it's not, it's done. We are in the world in which we need to write concurrent and asynchronous code daily, especially in .NET because it's very easy to do in .NET. And fortunately, it also means that the free lunch is over. The free lunch is a term that meant that whenever you write code, you know that in half a year or a year from now, a new Intel processor or AMD processor comes out, and your code will run faster. So you don't need to really think about it. Your code will just run faster with the next iteration, the next computer, the next big machine. Unfortunately, it doesn't happen anymore. Now we don't get faster and faster computers. We do get a lot of calls inside our computers. Even my father, which only browses the internet and get a bunch of email, half of them spam, does that with 8 different calls. And we need to write the code accordingly. So new language construct become the norm, await async, and tasks, and all of those things. And we talk about actor model, and how to use messages in order to enhance concurrency. And languages that were there all along but become more and more popular, like Clojure and Haskell, and all sorts of nice things. But it also means that we need to plan accordingly, because our code needs to run on as many processors as I have on my machine in order to be more performant. And so, on the other side, in the unit testing world, we see something like this. And this is from my own workshop, so that's fine. You see this simple unit test with 2 inputs, return 1 output, write an assert, and it hasn't changed much. Well, we do get new asserts from time to time and new ways to write our tests, but not a lot. So in the middle of this huge revolution, where things tend to run around in multi-threaded environments, unit testing remains the same from essentially the beginning of the century. And that is a problem, because if there's one thing I know about concurrent code and multi-threaded code, it's hard. It's hard because us people don't think that way. We only think in one thread, unfortunately. Some people are very good at multitasking and can do seamlessly 2 things at the same time, but in fact they are doing time sharing, because I yet to find a person who can talk on the phone and write a letter at the same time. Our computer can do it, but unfortunately we can't. And so it's hard to understand and grasp how things actually work because they work at the same time. And so when things run concurrently at the same time, I need to think about all of those layers of execution together. And that is a problem. It causes things to look as if they are semi-random. If you ever try to debug your code that uses tasks or threads or even await async, you'll notice something very strange happen to your cursor. You'll start following line by line, and then it will jump to a completely different method because some thread just woke up and drive you to the other end of your code. And it's very hard to understand what is going there. And on top of that, it seems like the computer is playing a small game of random throwing dices at me, because every time I run the code, it will run slightly different, with the different synchronization and the different things happen in different times. It might run longer or shorter, or something will run in the same time as something else in the first run, but on the second run afterwards. And it's very hard to really comprehend what my code does. Now, the code is not really non-deterministic. Code is always deterministic. But there's a lot of factors there. Most of them we have no effect of. Now, all of this is nice, but we want to write unit tests for this kind of code. And that kind of code, the asynchronous and concurrent code, is the exact opposite of how to write a good unit test. Because if there's one thing about a unit test, it should be trustworthy. I need to know when a test fails that there's actually a problem. I don't want my test to sometimes pass or fail, and I don't want my test to run differently the second time I run them, or if they fail on one machine, I want them to fail on my machine as well. I need to be able to trust my tests, not think that maybe there's something behind the scene that causes some problem. And they need to be maintainable, and the more threads you have on your system, the more processes you have on your computer, means that things tend to become more of a mess. In the past, when we used to start new threads by hand, writing new thread.start, it will cause the code to look very confusing. And we don't want our tests to be very confusing. We need to maintain them in as little time as possible. We don't want to waste time there. And finally, they need to be readable. And again, if I'll start using various synchronization objects over in my test, they won't be that readable as I like them to be. So I need to take this semi-non-deterministic world and test it in a very deterministic way. And that's a problem, because developers, when they see production code acting in that specific way, they try to take the same ideas to the test. Doesn't always work this way. I used to see it, well, I still see this test from time to time. If you've written it, that's not a bad thing, but there are other ways in which the developer will start 50 threads, make them run, then check at the end if something happened. When that test fails, it's very hard to understand why, even if there's a problem. And we need to stop doing that. Now, when you start to investigate certain problems, especially in this multi-threaded world, you can tend to see a group of problems, but those problems are not exactly problems. Those are more of smells, just like code smells. Code smells is a term. You know code smells? Ever heard about code smells? The idea is that just like a bad smell in the room, a code smell tells me that there's another problem somewhere. That is not essentially the problem, but something that caused the problem, or some way to know that I have a problem, but not exactly where. And those things happen in my tests. I know I have a problem, usually multi-threaded problem. The first one is inconsistent results. I can create inconsistent results with single thread, but usually when I start with multi-threading, some tests will start to pass and then fail seamlessly in a random manner. I have a test that worked perfectly on my machine. I run it in the build system for a week or two, and then one night it fails. I try to run it again, and it passes. And the day afterwards, it fails again. You know what the solution of a test that sometimes passes, that sometimes fails? What is the number one solution most people do? Ignore, yeah, we'll get to that. But before they ignore it, they run it again, right? Because then it will pass. Usually they are right. And that is the problem, because that specific test will cause your team to stop writing unit tests. The way it goes is that you run it again, and like the fifth or seventh time, you get fed up with it, so you leave it failing, because that test doesn't matter, and it has absolutely no value, because I can't catch bug with something I don't trust. And so we get used to that test being a failing test. And then other tests start to fail, but I ignore them as well, because I'm used to the build being broken. And after a few weeks, I can stop running tests altogether, because I don't care about the results. And I have seen teams stop writing unit tests because of this behavior. Now, when you have this inconsistent test, you have to make it either consistent or delete it as quickly as you can, because otherwise people will stop paying attention to whatever is running on your build system, and you don't want that. So that's one problem. Second is untraceable fail. You have a test, it failed, you look at the stack trace, because .NET, we get stack trace when we get an exception, very nice. It has nothing to do with the tests you've been running. In fact, some of the time doesn't really have a stack trace. So what happened there is that a test run started a new thread or task, then stopped, finished. The test succeeded, but that thread is waiting for you, and you run another test, and it comes back and crashes everything. And it's very hard to track those kind of failures because you don't have a stack trace. You don't even know which test caused that. And you need to have a very good understanding of your own code in order to really find out those problems. Because the test that failed is not the problem. It will probably pass on your machine. But the test that caused the failure, started a timer or a thread or a task somewhere else, is still messing up other tests. And it doesn't happen all the time, just if you get the right synchronization. And that's a problem. Tests that run for too long. There's a rule of the thumb, which you shouldn't take too seriously, but it's a good indication that unit tests should run less than a second. Because, hey, we're running everything in memory, testing very concise, simple part of our application, shouldn't take 10 seconds. And then I have a test that runs for 30 seconds, for example. I might have a problem there. I need to look in. Someone written a slip, or waiting for a thread to finish, or something like that, either in the test or the production code. I need to understand that in order to fix that problem. And it is a problem, because if I have something, even a test that runs as little as 10 seconds, means that 6 tests, such tests will run for a minute, full minute. And 10 of them for 10 minutes, I don't know about you. I'm not planning to wait that long to see if the test passed or failed. And finally, test freeze. What is test freeze? Usually it doesn't happen on your machine. It will happen in the build server. You just come and submitted something, and then you, after an hour or so, you check what's the status of the build. It's still running. It's still running because something got stuck there. It could be your build, could be someone else running 5 hours ago, and essentially you got a deadlock, which causes the test to freeze. It's waiting for something, or trying to lock something can't do that, which usually says we are handling multi-threaded code there. So all of those will tell me there is a problem. And then I need to find that problem. Unfortunately, that depends on how you wrote your code. No clear rules there. But once I do find it, I need to understand what I can do with it. And let's talk about it. This is a very simplistic view of software I used to write from time to time. You have a loop that runs essentially forever. Well, I did have a Boolean value there that I can set up, but essentially the server goes up and the loop runs all the time. And the beginning there's thread slip because I don't want to kill the CPU. And then I do some calculations and write something down, and that's it. So how do I test this? There are 2 problems with testing this kind of code. First of all, it's impossible to test something that never ends. Impossible to test an infinite loop. But let's say we somehow handle that. That's easily done. Set is alive to false somewhere. I have a slip in my test, which means that I'll start the test. It will start a new thread. That thread will go to sleep. My test will finish, probably fail, and then it will wake up, if I'm not that lucky. And then usually what I do in order to solve that problem is look at the code, say, okay, I'm sleeping here for 1 second, then let's sleep in the test for 2 seconds, right? And I've written this code, by the way, that's fine. And in fact, this code came out of, I did a code review to a colleague of mine. Not only is a very talented developer, but also sat through one of those sessions. And I tried to explain to him why this is a mistake. Essentially, if you write sleep in your code, that's a problem. If you write sleep in your test, it's a mistake. And the reason it's a mistake is because it's a test smell. If you need to sleep in your test, it means that you essentially trying to write something in your test that is non-deterministic. Because sleep, the way it works in C#, most languages, but C# is one of those notorious criminals in there, is that it will sleep for the amount of time equals or bigger than what you write in sleep. Which means that this test from time to time actually failed because the production code, while had 1 second to wait, waited for 2 or 3 seconds, and the test ended before the code actually finished. It will run for too long. 2 seconds is a lot of time for a unit test. Think about it. There's only a finite amount of tests you can write that will run in less than a minute if all of them wait for 2 seconds. And it's hard to investigate, because once this test fails, it could fail because of an actual problem or because you just haven't waited enough. And then people start increasing the amount of sleep, which just make the problem even worse. So we don't want to do that. Now, the problem with doing code reviews is that you need to be very passionate and caring and convince the other person nicely that he made a mistake, but he wasn't that convinced at the time. I needed to explain it to him. And in fact, only after something bad happened, he changed that code. Because there's something we need to understand about concurrency. If something bad can happen, it will, and in the worst possible moment. And in fact, that's what happened. It will fail either 1 hour before you go out to your weekend, or leave the office late at night, or 1 hour before you need to release the product. The test will fail. You have no idea why, and you have a problem. So you don't want to do that. And in fact, that happened to us. So that developer was convinced and said, okay, I'll change my test, I'll fix it, so there won't be any sleep in the test. By the way, he wasn't trying to be smart with me. He actually thought this was a good solution, because he removed the sleep. And it took me a minute to gain my ability to speak again after I've seen it, because I was so shocked, and then tried to explain what the problem is here. But yeah, that was back then. So this is still a problem. We need to fix that problem. How can we fix that problem? Well, there is one specific pattern. I haven't invented it. But the idea is to avoid the concurrent part altogether. Might look like cheating, but you have to be patient. The idea is that if I have a problem and I want not to have a problem, all I need to do is look the other way. And the pattern is called the humble object pattern. It's from the XUnit testing book. The humble object was created for something else. The idea is that I have this huge object with a lot of things happening there, and just creating that object in my test is almost impossible. So instead, I'll extract the logic I care about to another object, initialize it in my original object, and test only the small part that I care about. I usually do that if I only care about the logic. If you look again about this class, I don't really care about thread sleep. They probably work to some degree. I don't really care about new thread as well, probably work. I do care about the 3 lines in the middle, those which I want to test. That's where my logic is. And in unit tests, I try to test logic. So all I have to do is extract it to another class named message handler. And it has a method called handle new message, obviously. And then I can test it easily, because that class I can create has no thread inside, and problem solved, right? A lot of people are unhappy in this point, usually, because it does look like cheating. Who thinks I'm cheating? You can raise your hand. I won't be offended. Usually 1 or 2% raise their hand because you're polite. Okay, 3 this time. Yes, it is cheating. But essentially, what I do here is take the logic I care about and extract it from the rest of the method. But there are other ways. That's not the only way. Another thing I noticed is that people try to test too much things, and on the way you gain some things that you don't want to test. For example, here I have 2 classes. One will set the other one a message that in an asynchronous method will be handled later on. And I've been in support. I've support call for a client that tried to test all of that together, had a big, huge problem with it, because the message sometimes arrives, sometimes doesn't. And so if the message is sent from here to here, I want to somehow test this thing, but not necessarily as a whole, because it's very easily done once I break it into 2 different flows. Beginning till I send a message, which I can fake away. I don't really need to use a queue for that. I'll use a fake object or a mock if you prefer. And what happens when a new message arrives? Those are 2 different tests, actually more than 2, depending on the amount of scenarios I want to test. And then I can write the first test. That test will check that when I call create new message, then one message will be in a queue. I can use the real queue if I'm not causing it to actually start processing messages and throw an event around. And the second, easily written test as well. Now, in real code, you probably have more lines there, but you get the idea. Both of those patterns are what I call avoid concurrency patterns. This is the best possible solution if I can get away with it. What do I mean? I mean that if I only care about the logic, the rest is either trivial or done by some third party that I trust, like Microsoft, then I'm fine. I'll test the logic. I know that that specific piece of logic will work the same way no matter how many threads I'll spawn there or how many tasks I'll start. And I only care about how it behaves individually. But unfortunately, and that's the reason you feel a bit bad about it, is that I do not test the whole part of my system, all of the code. And that's fine, because in unit testing, we do try to test the logic and break our code into different parts, different unit of works, and then try to test each and every one of them. And it's not applicable in a scenario. If I'm using a weighted sync, probably won't work as well, because it does affect something. And that's probably not the end of the story. I'll probably have end-to-end integration, acceptance tests, whatever, in order to make sure that the whole system works. But I need to do that anyway, even without threading. So, okay, we avoided concurrency, but that's not good enough. Let's talk about other examples. Here I have timer. Timer's timer. It's important to say because .NET have several of those, right? There's timer's timer, there's threading timer. If you use a UI framework of choice, probably has a timer of its own. I don't like those. I don't like timers because essentially we're creating threads here in the background without noticing. It will behave weird no matter what you do. And then people try to somehow fix it with locks or whatever. But I have a timer here, and the timer will wake up, tick, and the method on timer elapsed will be called and do something very important. And that's nice. Unfortunately, using timer and testing timer is very similar to testing threads because you are creating threads. Timer's timer queue a new thread in the thread pool every time the elapsed time passes. And that is a problem. And then people start to write something like this. I'll set up the timer for a very short period of time, either 1 or 0. So it will happen immediately. And then I'll start my class with that timer, get a few ticks in, and maybe sleep, although some talented developer found a better way or not a better way, depending on how you look at it. So you wouldn't need sleep, and this test will probably pass without a sleep some of the time. And then assert something important just happened. I don't think that's a good test for the same reasons I don't like sleep. Setting something for a very small number, and you can do that with timeouts as well, if you like to write bad tests. And a friend of mine did that. Timeout 0, okay, the timeout just happened. I want to trigger the timer whenever I want it to happen, not wait for it. It's time-based, it's very fragile, it's very hard to get right consistently. It's very hard to investigate because that timer will do 2 things. First of all, it will start a thread, and if something bad happened, it won't come back. So when the test fails, you have no idea if you have a problem in your logic or the timer haven't come back yet. Maybe you haven't waited enough. And usually it comes with sleep, talked about that. But the second problem with timers is that this annoying little fella will manage from time to time to set another event, another elapsed event, another thread just before the test is finished. And it will crash your next test or the one afterwards when it comes back to do something and you have null references or whatever. So you don't want that. So what do we do with timer? For that, I call it fake and sync. I have a synchronization mechanism. It could be a timer, it could be a thread pool, a task pool. I don't want it to work all the time. I want it to work only when I want it to work. I want to tell it in the test, now something happened. And then I will trigger the actual logic I care about and check that it works. Essentially, just like running the test, only I control the synchronization. I'm in control of the time. And if you use datetime now, maybe you have similar problems. If you use thread pool, probably have the same problem as well. So how do we do that? This is one example. This is using Typemock Isolator. Anyone knows about Typemock Isolator? Okay. Well, Typemock Isolator is a mocking framework. I used to work there way in the days. And essentially, unlike MOQ mock or fake it easy, it doesn't use inheritance. It, in fact, changes your IL code that is as it being jittered. And so you can do something like fake instance of timer because timer cannot be inherited. So that's why I'm using Typemock Isolator here. So I'll create a fake timer over here. Here we go. I have a fake timer. It's written, or mock, if you like that word better. Pass it through dependency injection, which all of us use, obviously. And I have an elapsed event args, another class I can't really create. And this is a very messy API. It wasn't our fault, that's just how events work, that will trigger the event in this line exactly. So the timer doesn't work. Instead, I'll tell it, here, the timer just sent an event. And then I check, and everything is very consistent when I do that using those mechanisms because it just works. I just told it to work. And that way, well, timer works. If you have problem with timer, probably won't catch it with the unit test. Or you will, but you probably didn't intend to do that. So I can fake it away, keep my code the same. Same with thread pool. Anyone still uses thread pool? We have task now, right? So no one. But I can do a similar trick. I can tell that thread pool when someone queue a new thread and so on. Also, I can't really because those mocking tools have some limitation. They can't fake part of the system, or if you're using MOQ mock, like most .NET developer, or fake it easy, like I do, then you can't actually inherit timer. You can't, because they made it a sealed class. And then we have a problem. And the solution is, well, you probably, if you played with mocking for some degree, you know what the solution will be. Just wrap it with your own class. And the same example with timer, just this time, I'll create my own interface called iTimer. Small side note, I usually do that regardless of testing because I don't like how timer works. If you create a new timer and the elapsed time is shorter than the time your method actually runs, you'll get a bunch of concurrent threads running. So my timer makes sure it doesn't happen. And I have elapsed and start and stop. It's very easy to create your own class that inherit that interface, replace your production code to use iTimer instead. And then you get to write this test, fake it easy, or mock, which is essentially exactly the same. A fake of iTimer, class with timer. This is our fake it easy, raise an event, and true. And that's it. So solved our problem. And if I can do that, that's fine. But there are other places where I can't do that, especially when something else happens, you need a sync task for that, and then you either need to run everything asynchronously, and then you have another problem. Because testing that something happened when you have another thread is possible and doable. But testing that something didn't happen when you have another task or thread is impossible. How long can you wait to see that an event wasn't called, that something wasn't saved to the database? Will you wait a second, a minute, a day? If something goes away and comes back in its own time, how much time do I need to wait? And for that, I need to do something different. And I call it run in sync. Run in sync essentially means that I have code that when it runs in the test, instead of running asynchronously, instead of spawning threads, it will run in the same process, in the same thread, only in my test. In the real world, it will do whatever it does. In my code, in my test, I will somehow raise a flag and do some magic, and it will run in a single thread method without the code noticing. And there are several ways to do that. The easiest and simplest of which is this. You see, I have here a calculator, add a sync. I told you I like the example. And all I need to do is add and await, right? And now in my test, it's seamlessly run in the same thread, right? All of us did that. That's too trivial to talk about. The reason I'm talking about it is because of this. This test cannot run because of, well, language/unit testing limitations, because it's a void method and it cannot await the test. Now, most .NET unit testing framework know about task and await async. It wasn't in the beginning, but now they do. But in case of Microsoft unit testing framework, also known as MS test, unless you turn it into a task, that test cannot run. That's the reason it doesn't have a small green circle there. So simply enough, just add task there and you can await. But that's not the reason I wanted to talk about. I want to talk about something else. Here, I have a class I want to test, says so. And that class will send an event at some point, and I want to mark it that it was called. I want to start the client and wait until it was called. Now, that's all fine, but if we look inside my class, when I call start, it will start a new task and message and run and invoke my message somewhere in his own leisure. So obviously that test, well, if I run it now, it will pass and then fail and then pass and then fail and so on. And unfortunately, the guy that wrote start didn't want me to await for that specific method, so I can't use await. But I can use a completely different trick. There's something in the tasks world, the TPL, that is known as the task scheduler. Ever used the task scheduler? Ever found yourself playing with this? 1, 2, 3, 4, 5, 6, 7, 8. Wow. Because most of the time you don't need to. And in fact, I did something very strange here. I've added a task scheduler and told it that it should be the current task scheduler, which seems weird because that's the default behavior either way. If you don't specify anything, it will use the current task scheduler, the one that is set up. There's a field inside task scheduler, static field, .current. But the reason I did that is in order to write this test. Here we go. Which look a bit strange to begin with. This is a test. Inside my test, I'll start a new factory, start new. So essentially, I'm making things worse for now. I'm seamlessly starting a new task in my test to solve another. It's like fighting fire with fire, doesn't work. But it does work because of something I did here. I've used my own current thread task scheduler in order to switch the current task scheduler with my own. And that current task scheduler, it looks confusing a bit because that's implementing. But essentially, when someone will try to run a new task, it will immediately run it. So that single-threaded task scheduler, it doesn't create a task like you expect it to, just run on the same thread. You tell it start new, but it won't. And I need it for my test, because once I set up the current task scheduler as my current task scheduler, then that code inside the production code will get the same scheduler magically and will run in a synchronous manner. I was so very happy with myself, so I wrote a blog post about it back then. And well, the slides will be available. You don't need to copy the URL. But there are other ways. That's not the only way to do that. You can use dependency injection. I've seen people do that with datetime now. You have a Lambda that you inject that will return the datetime, and in your test, you pass something else, or you create a class around it. You can use preprocessors. You know those when you use #if to compile differently for your test or for your production code. I don't really like that, but you can. Maybe you don't have any option. And probably talented developers that you are, you can find other ways in order to make sure that in your test, the code will run synchronously. I've done it before, usually either with dependency injection or Lambdas or both, where I pass a different way to run things when I'm in the test. Or I create singleton or some other dependency that can receive whatever you want to run and either run it in the same thread or another. We do that in production all the time. We can do that for our tests as well. So those are running single thread patterns. I'm not avoiding the problem, but I'm not really running my own code. I'm trying to synchronize it in order to gain insights, because there are things I can't test properly if things are not running on the same thread. And I gave you one example. That's something that didn't happen. And either fake the synchronization object, timer, thread pool, whatever, or do something in your code to run it a bit differently without hurting it too much. So that's all fine, that's all well, but it's not the end of the story, because sometimes I do need to run all of the tests, but in a predictable way. I need to be able to run my code with my asynchronicity or the threads or whatever, because maybe I can't. I can't change production code all the time the way I wanted to. Maybe I don't have time, maybe it will break the code in some weird way. And sometimes there's it's a logical idea to test everything in the way it was written. In fact, that probably is your first thought when we talked about unit testing patterns. And when I have no other options, I can do one or two things. The first of which I call the signal pattern. The signal pattern is simple when you think about it. You find somewhere where your code goes outside, call some dependency outside of your code. And you know, if you know something about that dependency, that it will only happen after the thing you were trying to test happened. For example, you send a message or save something to the database. And then you fake that specific call. And instead of running, because you don't want to mess things up and call the actual database or the server or whatever, you just raise the signal. And you wait for that signal in your test. And it looks something like this. Here I have a difficult calculation, runs in another task because I don't want to spend a lot of time. It will calculate the result, which I care about and want to test, and then call another class to do something. The way to test it is to fake the other class. Here we go. Let's do that line by line. Okay, I'll create a wait handle. You can use manual reset event, slim or otherwise, that's a test, or counting events if I want to wait specific amount of time of that thing to happen. And then create a fake other class, that dependency, which I should have faked either way, because in unit tests we don't want to call external dependencies. And create my class in which I want to test. And run the difficult calculation, and wait until the wait handle is triggered. Now, I'm doing it, you can notice I'm waiting for a lot of time. That's on purpose. The reason I'm waiting for a lot of time is so I'll have to make sure that the reason the test has failed is not because I haven't waited enough. And the good thing about it is that unlike sleep, I will only need to wait that amount of time. 10 seconds is a lot of time for us, only when the test fails. When it passes, it will take less time because the wait handle will be triggered and I get was called. And the first thing I do is not check the response. I'll check that it was actually called. And if not, in unit testing assertions, I can give a proper message. And this is the only thing, the only place I can think about which I actually need to write that message. Because when the test fails, you'll have no idea why. So help your future self and write something informal there saying, I've waited for that event that happens because of this operation and it didn't happen. You'll thank yourself in a month or a year from now. And only after I made sure that the event was in fact called, then I can check whatever I care about. And that way, I'll get to run asynchronous code with the task inside in a very predictable manner when it passes. When it fails, well, I have the same problem as with sleep, which means I'll need to debug because I have no idea why it happened. The timeout might not be big enough, but usually because of some internal problem. And there's another pattern, I call it busy assert. A friend of mine came with that idea. He had a bunch of tasks running around and wanted to make sure that something happened. And if it didn't happen, wait a bit and try again. If it didn't happen, wait a bit, try it again, until a specific amount of time has passed. And a busy assert will look something like this. This is a busy assert. The condition is we wait till the result equals 5, in this case. By the way, you have to use the lambda function because you want it to reevaluate the value all the time. And if you get it wrong, you won't understand why this fails all the time. At least it will be deterministic. It will never pass. So you needed to get the result back every time, not just once in the end of the test. And here, how many times to retry, how much time to wait between, and if it fails, yes, a good error message will be nice because people won't understand. And the implementation is very simple. While condition is false, next iteration, if the number of retry is passed, then thread sleep. Now, the nice thing about this idea is that apparently I wasn't the only one who thought about it, or my friend for this matter, because if you use NUnit, they implemented it. I didn't know about it, but NUnit has assert.dat, which looks exactly the same or similar, is equal after so-and-so time with polling interval of whatever. So it seems that we came to the same conclusion independently. And a busy assert will essentially wait until something happened and keep checking it until either the timeout has passed or the condition is true. And that's excellent because I can test a lot of things that otherwise I have a lot of problem testing. And those patterns, I call it the synchronized test because I'm synchronizing the way the test executes. I'm waiting for something. Either I'm waiting for an external event I just put there, or I'm waiting for some condition to happen, either busy or otherwise, doesn't matter, I'll still have to wait. They are very good if you have no other option. And it's harder to investigate failure because the failure will not only tell you what didn't happen. It's not exactly that informative. Depending on your code, could be easy or very hard to do. And you cannot test that the call wasn't made. The good thing, or semi-good thing, is that the test will run as quickly as possible when it passes, so it won't waste your time on a day-to-day basis, only when it fails, and then it's okay, you can wait 10 seconds to find out you have a problem. And it's very deterministic. If you do your work correct, if you use them correctly, then you get very deterministic tests out of them. But due to those reasons, I will only use those options where I don't have anything else I can do. If I can do any of the other two things, I prefer to do them and not go there because I have less control, and it means that I'll need to work harder when the test fails. So what did we have? We talked about 3 groups, and there is a good reason those are 3 groups. I came to a conclusion you should try them in this specific order. First of all, you can avoid concurrency. If you can avoid concurrency, that's the best solution for you. You wrote the code, you know whether or not the logic can be splitted, divided completely from the concurrent, from the threads, the task, whatever. Either by using the humble object, extract to class, or even extract to method, or break your test into several tests, each of them tests a different part. If you can't do that, you want to synchronize the test run it in a single thread, either by faking the synchronization, the threading object, the thread pool, the timer, either wrap it with your own class with a nice interface, or fake it completely if you can, or use the programming trickery in order to make sure that in your test, the code will run slightly different. And finally, if we don't have any other options, we have 2 patterns that will help us. Either wait for an event or busy assert until it happens. And following those 3 guidelines, those 3 rules, I managed to write very deterministic tests very easily. You get used to the idea. And I yet to find a problem I can solve with them. The code, by the way, I forgot to say, all the examples, including those in the slides and those I didn't show, are on GitHub. Feel free to download it. And under the helper, the slide will be available soon. And if you have any questions, I'll be happy to answer. Okay, thank you.